Hello class, welcome to Algebra Concepts, Lesson 8.5, Simplifying Radical Expressions. By the end of this lesson, you should be able to simplify radical expressions. Today is day 2. Yesterday we practiced simplifying just radical expressions with numbers, with variables, and then also multiplying radicals together. Today we're going to talk about division, okay? So today is just about division. I thought I would include this little slide here again. These are the numbers that are the best to test. You always want to start by seeing what's the biggest number that can multiply into whatever number you're dealing with, okay? These are your perfect squares. If you find the biggest number that multiplies into, you will be able to save some time when simplifying radicals. Okay, so now let's practice simplifying square roots. So let's start with, if I have a square root divided by a square root. This is something that can look intimidating. Having so many square roots on a page tends to make us freak out at first because we're not used to seeing so many square roots, at least yet. Okay, so what you're going to do is you're going to see we have a square root of 16. Okay, so what is the square root of 16? The square root of 16, that's a perfect square. That's just 4. So I'm going to write 4 on the top. And then on the bottom, I have the square root of 49, which is just 7. So this first fraction just turns into 4 over 7. There aren't any square roots left in it. And sometimes that'll happen. Okay, now looking at this next one, I see I have a square root of 20 on top and a square root of 5 on the bottom. So let's break down that 20 like we did yesterday. We said, okay, what's the biggest number, perfect square that multiplies into it? That would be a 4. And 4 times 5 gives me 20. So I have the square root of 4, which is 2, times the square root of 5 on top. And then on the bottom, I have the square root of 5. Now, what's really cool about this is whenever you have the exact same thing on the top and bottom of a fraction, it cancels and it just becomes the number 1. So this would become a 1 and a 1, because anything divided by itself is 1. So 2 times 1 is just 2 over 1. So my answer for this problem would actually just be the number 2. So again, this one, we didn't have any radicals left. But let's look at an example where we do have a radical left. So if I look at this, I have the square root of 30 on top and the square root of 6 on bottom. So again, I want to think, okay, what's the biggest perfect square that multiplies into 30? So does 25 multiply into 30? No. 16? No. 9? No. 4? No. So none of my perfect squares multiply into 30, which means that's as simplified as it can be. But looking at this fraction, I know that 30 is also divisible by 6. So I could do the square root of 6 times the square root of 5. So I would have square root of 5 times the square root of 6 all over the square root of 6. And then, just like in this last example where the square root of 5 was on top and bottom and it canceled, same thing goes for that square root of 6. So this would just end up being the square root of 5 times 1 over 1. Or you can just leave it as the square root of 5. Okay, so hopefully that doesn't seem too bad so far. If you have questions about that, please be sure to reach out for some help. Otherwise, you can go ahead and start solving this one on your own. Good luck. For this problem, hopefully you ended up with just the number 3. The way I got there was I had 72. I'm sorry, I can't stop yawning. 72 split into the square root of 8 times the square root of 9. And then I saw I have a square root of 8 on top and bottom, so those cancel. And the square root of 9 is just 3. So that's how I got 3 for my answer. All right, so we've done some simplifying where it works out nicely. Now let's do some more square roots that maybe don't work out as nicely. So you can see, first of all, it's written in a different way. You can see now it's all under the same square root. It's honestly the same thing as if I were to write it the way it showed on the last slide, okay? These are both the same thing. Now, looking at this, the square root of 10, okay, I could split that into the square root of 2 times the square root of 5 over the square root of 7, but none of these numbers match. So you might be thinking, hey, Ms. Johnson, we're done. It's just going to be the square root of 10 over 7, over the square root of 7. Yes and no. In order to be fully simplified, you actually cannot have any radicals in the denominator of a fraction, meaning there cannot be any square roots on the bottom of a fraction. So what you do is you multiply by 1. And again, you might be thinking, if I multiply by 1, there's still going to be a square root on the bottom. So why are you saying that? And you'd be right. Multiplying by 1 doesn't change anything. But what if we multiply by 1, but it's not written as a 1? Meaning, going back on that last slide, or even back here, when I had the square root of 5 over the square root of 5, that became 1 over 1, right? So what we're going to do instead, in order to get this square root to go away, we're going to multiply by whatever's in the square root on the bottom. So I'm going to say the square root of 7 over the square root of 7. This is the same as multiplying by 1. It just looks different than 1. It's a 1 in disguise. It's disguised as the square root of 7 over square root of 7. Okay, and the whole reason we do that is because when you do the square root of 7 times the square root of 7, that's the square root of 49, which is just the number, which is just the number 7. And then on top, all we have to do is say 2 times 5 is 10, times 7 is 70, and those are all still under a square root. So this would be my final answer. Okay, so I don't have a square root in the bottom anymore. Let's try another one, because I know that can be tricky. All right, so I can do the same thing if I want. I can split it up and say square root of 15 over the square root of 12. And I could say square root of 15 is the square root of 3 times the square root of 5 over the square root of 3 times the square root of 4. And if I do that, I have square root of 3 over the square root of 3, which is just 1. Then I have the square root of 5 on top, and the square root of 4 is just 2. And that's perfect. That means that I'm done. So as you saw in the last example and then this one, it's possible to have a final answer where you have a square root on the top of the fraction but not the bottom. Okay? You just can never have a final answer that has a square root on the bottom. Okay? Let's try another one. So again, square root of 56 over the square root of 12. So if I were to break up 56, I think 56 is divisible by 4. It is. So I'm going to do the square root of 4 times the square root of 14, because 4 times 14 is 56. 12 I'm going to break up into the square root of 4 times the square root of 3. And then from there, those 4's cancel, and I'm left with the square root of 14 over the square root of 3. I'm not done yet, because I still have that square root of 3 on the bottom. So what I'm going to do is get rid of that. So I do that same process where I multiply by 1, but it's not just a 1, it's a 1 in disguise. And the disguise is the square root of 3 over the square root of 3. So now I do 14 times 3, which is 42. So I have the square root of 42 over the number 3. So my final answer is the square root of 42 over 3. And then I am all done with my problem. Okay? So hopefully you're starting to get the hang of that. If not, ask questions. I'm here to help. I like helping you guys. That's why I signed up to be a teacher. Okay? So I want you to try the square root of 54 over 8. Go ahead and simplify that. Good luck. Okay, for this problem, I realized I maybe got a little ambitious with the problem that I chose for you guys. So if you were very frustrated and confused by this problem, I am sorry. But I decided I'm going to keep it in the video because I can explain it to you, okay? So if I start with the square root of 54 over the square root of 8, I know 54 breaks up into the square root of 6 times the square root of 9. The square root of 9 is a nice number. It's just 3. So the top becomes 3 square root of 6. And then I see on the bottom I have the square root of 8. And the reason this problem got so messy is because that 8 has a perfect square in it. Okay, so, but I haven't taught you that other method yet. So I'm going to do it the way that I just showed you. So square root of 8. So that means to get rid of the square root in the denominator, I needed to multiply by 1 in disguise of square root of 8 over square root of 8. So then I had 3 times the square root of 6 times 8 is 48 over 8. And then I had one more simple thing to do with the 48. There's a perfect square in it. It's 16 times 3. So 3 times the square root of 16 times 3. Square root of 16 is 4, so I have 3 times 4 times the square root of 3 over 8. 3 times 4 is 12, square root of 3 over 8. And then the last step, 12 and 8, if that was just a fraction on its own, if I said 12 over 8, and I said, hey, I want you to simplify that fraction, you'd say, okay, 4 goes into 12 3 times, and 4 goes into 8 2 times. So that's how I went from 12 over 8 to 3 over 2. And when you simplify the numbers outside of the radical, you leave the ones inside the radical as is, okay? You don't change those. You only change everything that's outside, or you only change everything that's inside. You can never mix and match and do one of each, okay? Let's move on to another example. So here we go. We have the square root of 4 on top. So I'm going to leave that there for just a minute, okay? And then I have 2 times the square root of 32. 32 is the same thing as 4 times 8. So I have 4 and then 8. So I see I have a square root of 4 on top and bottom, which means that this square root of 4 becomes a 1 over 2 square root of 8. And now I have a couple of options. I can either multiply the top and bottom by the square root of 8 over the square root of 8, and I would get the square root of 8 over 2 times 8, or the square root of 8 over 16. And then I'd say, hey, there's a perfect square in 8. It is 2 times 4, so square root of 4 is 2. Square root of 2 can't change, so then I'd have 16. I'd say 1 times the square root of 2, or just square root of 2 over 8, because 2 over 16 becomes 1 over 8. So I could do it that way, or from here, I could say 1 over 2 square root of 8. I could say 1 over 2 times the square root of 4 times the square root of 8, or not 8, sorry, times the square root of 4 times the square root of 2, right? Because that's me just splitting up that square root of 8. And I would have 1 over 2 times 2 times the square root of 2, or 1 over 4 square root of 2. And then all I have to do is multiply by the radical that's the square root of 2 on top and bottom. So then I have 1 times the square root of 2 is just the square root of 2 over 4 times the square root of 2 times the square root of 2. Square root of 2 times square root of 2 is just the square root of 4, which is 2. 4 times 2 is 8. So you could see I end up at the same thing. So I did 2 different ways of solving the same problem. One of these ways might be easier for you. Maybe it feels the same. Maybe you think they're both easy. Maybe you think they're both hard. No matter what, like, ask questions, I'm happy to help you, and we can walk through all the different steps, but usually one way makes a little more sense to each person, okay? So then looking at this one, I have the square root of 5 over 3, and then I'm going to break up that 20 right away. I'm going to say, hey, that's a square root of 4 times the square root of 5. My 5's immediately cancel. I don't forget about how that square root of 5 becomes a 1. Then I say 3 times the square root of 4. But the square root of 4 is nice. Square root of 4 is just 2. So I have 1 over 3 times 2, or 1 over 6. And that's my final answer. Okay, so if you pay attention to see, hey, this worked out, this is a perfect square. I don't have to do that part where I multiply by 1 in disguise. I get to just do the square root. Always be on the lookout for that. That'll happen sometimes, and sometimes students will go through this whole process up here because they think they have to, because they didn't pay attention. Oh, this is a perfect square. Okay? So if you have questions about that, please be sure to reach out for some help. I'm happy to help you. And here is the last problem I want you to try on your own. Good luck. All right, for this problem, hopefully you said your final answer was 9 square root of 10 over 5. You can see I started by splitting up 45 into 9 times 5, and then square root of 9 was 3, and then the square root of 5 on top canceled with, when I split square root of 50 into 5 times 10, became a 5 there. So those canceled, so I had 6 times 3 on the top and square root of 10 on the bottom. And then I had 6 times 3 is 18 over the square root of 10. I multiplied top and bottom by that square root of 10 to get 18 square root of 10 over 10. I saw, hey, 18 over 10, that simplifies to 9 over 5. And then I left my square root alone. Okay, so if you have questions about this problem or anything else, please don't hesitate to reach out for some help. I am happy to help you, and I hope you have a great day.